the Sci-AI podcast. This is episode number 6, and today I have a great guest with me. Her name is Abigail Diaz. Abigail is a planetary scientist and lunar exploration expert working towards establishing a permanent human presence on the moon. She is the first lunar geologist working full-time for a private lunar exploration company, iSpace, where she is responsible for landing, site selection, and the integration of technical and business requirements into the mission's goals and objectives. How amazing is that? She also has a PhD in geology from University of London and a master's degree from International Space University. It is indeed my pleasure and good fortune to have Abigail on this podcast. So let's get forward and talk to her. Hi, Abigail. Welcome on the podcast.
Hi. Thank you for the invitation. I'm really excited of being here with you. Yeah. Yes,
absolutely. Thank you. So I have given a brief introduction of you. Would you like to add something to it?
No, I think it was perfect. Thank you very much.
Okay.
It was great.
Awesome. Great. Let me then open my inquisitive mind and start asking you the questions that I have for you.
Yeah.
Okay, so how do we create an environment on Earth that mimics the moon and its challenges so that we can do extensive research for human space exploration?
Okay, this is very difficult because actually, the moon has some characteristics that it's impossible to mimic exactly like them here. For example,
Right.
It's like we cannot create the microgravity as we have it on the moon. We cannot create the lack of atmosphere as we have it on the moon for permanent human presence. But what we can do is try to understand parts of the moon. It's very difficult to actually mimic the surface of the moon here on Earth. Actually, the lack of atmosphere or the low gravity is really difficult to have it there. Or, for example, the bombardment of the cosmic rays is very difficult to mimic exactly like that here on Earth. Or even more complicated, is very difficult to have everything together at the same time. But what we can do is try to find analogs on Earth that can replicate some characteristics. For example, there are missions that are called analog missions that happens in places like Hawaii or Iceland, because these areas have type of material that are very similar to the moon. They are these igneous basalts that is very similar to what we can encounter to the moon. So that can help us, for example, to understand the surface, how we can move around the surface, and how we can deal with craters or with other features that the terrain that we can see on the moon. So it's not that we cannot create exactly the same situation like here on Earth, but we can use what we have and try to replicate. And for other areas, like for example the cosmic radiation, we can use the International Space Station. So we can use to do some experiments that help us to understand also how that radiation will affect in the lunar surface.
Mm-hmm. Excellent. That's a great description of it. So in your publication, you have worked on a topic that, I've read your publications, and you've worked on a few topics around crowdfunding and a new space economy. So what is it? And can you share how will this help in space exploration in the future?
Yeah, this is a project that took place years ago within the Space Exploration Working Group at the Space Generation Advisory Council. And I did it together with some colleagues from the Space Exploration Working Group. And what we're trying to understand is what impulse some companies to actually use crowdfunding as a source of funding for their exploration challenges. The thing is what we during that work, what we did was interview several people. We interviewed several CEOs and people in charge of several startups related to space exploration, we asked him the topic. It's like, what do you think about using crowdfunding? And our fundings were like, although it can be helpful, actually the crowdfunding, it could not be used as a solely use of funding for a startup.
Yeah.
And like, because we understand that, taking funding for a space exploration company is very difficult. Crowdfunding can be a little part of it, but it cannot be relied on that only. So they have to find alternative fundings. So it was a very interesting project because it was the first time that actually this question was asked. Even also there were many startups using crowdfunding, and yeah, it was really nice. And and many projects that we did within this space exploration working group at the Space Generation, it was really, really, really good.
Fantastic. So is it backed by a lot of ventures and venture capitalists, and are there funds coming in for this initiative?
Well, the crowdfunding, to be honest, I've been out of the crowdfunding project since we did it. Yeah. I mean, for that time, when we did that project was completely voluntary. I mean, we didn't have any startup putting money or anything. It was us just because we wanted to know how this was. I must mention that it was 2015, 2016. Okay. So it was a time that the space exploration startups were starting to appear. I mean, it was SpaceX, but they were very timid startups coming up, and this was like we did a research that actually many were using crowdfunding. Fortunately, many of these startups that use crowdfunding, as we suspected, and we put it in that project, they didn't succeed, unfortunately.
They didn't show up.
No, unfortunately, no. And many of them, they were great ideas. They were really, really good ideas. Yeah.
Okay. Okay. Good to know that. Yeah. Should we go to Moon or Mars? Like, how do we decide? Or should we go to both? Of course, because of the distance, Moon sounds like a great idea, but it doesn't have an atmosphere, as we know. Should we make, as it is always proposed in science fiction books and ideas in science, that we should make base on the Moon and then shoot ourselves for further travel to Mars and other places in space? Is that how it is going on at iSpace and other agencies as well?
Okay, it's like why we have to choose. I mean, why we choose Moon or Mars? No, the idea is go to both. Yeah. And actually for going to Mars, one thing that will help us a lot is going to the Moon first. Why? It's like what people are researching, including iSpace right now, is like understanding what are the resources available on the Moon that can help to make this travel further to Mars or other planets or other moons. So it's like on the Moon, there is this resource that is oxygen, and there is also water ice that can be used as a propellant for rockets. So actually, if we have permanent presence on the Moon from where we can launch rockets to Mars, it will be cheaper because the Moon has less gravity. So it will require less fuel. We can put more cargo on that, and we can use the Moon as a base to go to Mars. So actually, I think that we should go both. Also, we can use the Moon as a research station for how humans adapt to spending long periods of time in low gravity or with the cosmic radiation to understand materials that will shield us for the cosmic radiation, so we can go to Mars more safely. Because it's not like just going to Mars. It's like it's the trip until Mars that it's few months. It's like at least 6 months. So it's like we should use the Moon for having a permanent presence there and like a launch place to go further. And Mars will be the logical next step after the Moon.
Makes sense. Correct. So I'm digressing a little bit, but when it comes to Moon, does it have a closer orbital connection to Mars, so that if you put a base there, would it be much more easier, other than the gravity factor that you mentioned? Would it be more easier to go to Mars or to other planets from Moon because of the orbits?
Well, it's not that much the orbits, as it is the factor of the chip of using the fuel from the Moon, because it will require less fuel that we launch from the Earth, because the Earth has more gravity, so we need more fuel to reach the escape velocity. But also we can do so many experiments and science on the lunar surface that can prepare us to go to this travel to go to Mars. As I mentioned, we can do the material science. We can experiment with how affect the entire environment or the being in close areas, isolated from the Earth for astronauts for long periods of time. We can do obviously researching in plants, in food, in life support systems. So actually it can be used for many things, like a place not only as launchpad, as I mentioned before, but also for experimenting. So we can use it to
other
go
things
further. Yeah.
Fantastic. Yeah, that's a good point. That's a really good point. Not to choose between Moon or Mars, but actually go for both and make one as a station and then launch for the other one. Fantastic.
Yeah, the thing is like going step by step. We go first to one place to another, step slow but steady.
Right, exactly. That makes more sense. Correct. And going to Mars right from Earth, we have seen it already with these Perseverance rover and the other rovers that NASA had sent. I mean, it takes really like a long time, and also that you cannot just go or launch at any time. Mars and Earth, are badly positioned. So there is a specific time that you can launch from Earth to go to Mars. And even that takes about 8 months. So, yeah.
Yeah, it takes, I mean, obviously it takes more for the rovers or for robotic missions to go to Mars, because when you have humans, you try that trip is as short as possible, because human doesn't like too much being on the space. It's like it's really uncomfortable because we are used to being on Earth. So it's like, okay, we need to do it as short as possible. And yeah, one thing is that probably it will take shorter time. They say that 6 months. The thing is like the window opens 6 months of trip, and then you have to stay on Mars 2 years to be able to go back to the Earth.
Exactly. So, yeah, absolutely. Great point. Thank you. So let me come on to the next point that I have is, how do planets, stars, and galaxies form? Like, how do they come into existence in any star system or in any galaxies?
Yeah, so basically imagine you have at the beginning a cloud of dust, material, break material is just floating around. So when this material is floating around, little by little they start to go together. So there is a word that is called accretion. So when there is this huge accretion of this cosmic dust and these materials, they form the stars. But it's not the only thing that they can form. They also can form planets. So it's like practically everything, planets, comets, asteroids, everything, it comes from this cloud of dust that start all together to form this type of bodies. Like they form suns, they form planets. The planets, they are attracted by the sun because stars have higher gravity. So they start get closer to the star, and they start to go around the star, and the star also tends to get together because they have higher gravity. So they get together and they form these galaxies and these clouds of more stars, these galaxies. So, and that is basically how it's formed.
That's fantastic. That's great to know. Yeah, right. So then building on to that, can we ever be able to travel beyond our solar system or our galaxy? This is when we know that all galaxies are, traveling apart from each other as space is expanding, perhaps more than speed of light. If that is the case, will we ever be able to travel so far, is it going to be like generations after generations living on a spaceship like they shown in these sci-fi movies? And then after thousands of years, reaching the other star system where we may find a habitable planet like in the Goldilocks zone. Or do you think we should send only the most advanced robots, instead of humans, who can take our eggs there somehow and then propagate life for humans on that planet? So what, according to you, are the methods of travel possible in the future, like ranging from now to 100, 200, 300 years?
Well, unfortunately, today we are just trying to reach Mars as human. I mean, we reached the
Yes.
moon. It was successful. We sent people to the moon, and they came back, and everything was great. And now we are trying
Right.
to find a way to make humans travel safe to Mars. And actually, it's super complicated. And I'm not just talking because it's 6 months. It's because it requires the human body to get adapted to that. So actually,
Right.
to go beyond our solar system or even beyond, I'm not really sure. Maybe in the future there is new technologies that we cannot even imagine right now. Personally, I think
Correct.
that is going to be very long. I mean, still it's going to be a long
Yeah.
time until that
Long
could
time.
happen. I mean, I doubt that we are going to see that. But
Right. In our lifetimes.
yeah, definitely. But what we can do, and we already did, is like we are sending robotic probes to somewhere else
Yes.
far, going farther. And I think that the robotic is a good option to go to places where humans cannot go, because it gives us we can see, we can explore, we can know what is going on, but without actually having the danger of being there, or with the restrictions that means to have humans in this risky situation with all the life support systems and everything that is come around human exploration. So if in the future humans can go further, who knows? Maybe. I wish.
Correct.
I don't know. But it's
Right.
very complicated. And right now, I think that we should focus in trying to go to Mars, for example, and go back to the
Yes.
moon
Yes.
and stay on the moon.
Yes. Correct. So you also mentioned in a few questions back was about the bone density. I think losing bone density and radioactive things affecting humans if we go to even till Mars.
Yeah.
Can you talk about that a little bit then?
Yeah, it's like the travel. I mean, the humans are meant to be here on Earth. I mean, we are used
Correct.
to this pressure. We are used to have an atmosphere. We are used to this gravity. So actually, when we go to space, even although we don't go very far, when we go to space, we are in another environment that we were not built for survive there. So for
Right.
survive, we are using all this life support system, the spacecraft that keep us alive. But actually keeping us alive doesn't mean that it's still our environment. So for example, astronauts in the ISS, they have to do a lot of exercise to try not to lose too much bone density, because if not, they came to the Earth and the bones start to break like if they were really old people. So
Right.
that is one of the effects. Cosmic radiation, despite that you are in a protected environment, relatively protected, because you still are being impacted by radiation. And this
Right.
radiation can cause cancer, can cause many other problems in the vision. If you go, so it's like, if you go to the moon as well, you have other problems like the dust that can cause problems in the lungs. So it's actually like, it's hard because we try to go to a place that we are not built for. We are not. It's like in the same way that we cannot stay out of the spacecraft without a suit. It's like we will
Right.
die. So
Right.
we need to understand really well what are the risks and how we can make them less risky. How we can improve our health and have not all these problems that affects these physiological problems that affects the human body when we are on the space, if we want to go to be on space for long periods of time.
Correct.
So all this sorry?
Right. No, go ahead.
No, so all this research is being done in the ISS, but I hope that also could be done on the moon.
Yeah. Fantastic. So is this the reason why, because of these issues of cosmic radiation and bone density problems and how to cope up in such a harsh environment as Mars or Moon, is this the reason why we could not go for like almost 50 years now? I mean, when have we gone last to the moon? 50 years back, right? And it's been a long time, and we have technologically so much advanced as well now, but we're still not gone yet. So are these some of the scenarios, the reasons why they could not go?
No, well, in the case of the moon, we go there quite often, but usually pros, not humans. Since 1972, that was Apollo 17, humans have not go back to the moon. But that is mostly like, and this is very sad to say, but it's a question of money. Because actually going to the moon is like, we did it. And we did it in the 60s with much less technology that we have now. And we have the ISS around for years, and they are fine. The astronauts are surviving. They're quite okay. So we could go to the moon, definitely. The thing is, like, for going to the moon, especially if you go with humans, it's a lot of money. Because it's much expensive. That actually is like, okay, if we can send orbiters, or if we can send rovers and they do exploration and they do the experiments and the analysis that we want to do, at this point it's like, okay, maybe it's not necessarily go. However, things are changing, and and there have been some announcements from NASA, from China, from many countries that is like, no, we want to go back to the moon with human presence. So actually, this is the next step, and it's really exciting because this is really something that you and me are going to see. So that is really exciting. Yeah, I haven't seen, obviously. I was not alive when the Apollo mission happened. Right. But it's really exciting that we are going to see, and probably sooner than we think.
Yeah, we were hearing about some of the news that NASA is planning to go in 2024, but I don't know how realistic that is, because usually it takes a lot of preparation and time for them to sort of launch this kind of project.
Mm-hmm. So the time is going to be shorter depending on the amount of money that they invest on it, because I mean, they did it in very few time with less technology, from zero to the moon practically in the 60s. So it's like, depending how much investment they do, it will be faster or later. But not just NASA. It's like there are many other nations that they are doing great things. Like, I mean, for example, in the case of China, they are going super fast, and they are already considering go. China is the only country that have been able to land in the far side of the moon, for example.
Far side of the moon, exactly.
Yeah, and that requires like a lot of technology. And they also, they already mentioned that they want to go to the moon. I heard just a couple of weeks ago, I heard that Egypt has interest in actually sending some Egyptian astronauts to the ISS and eventually to the moon. So it's like, it's really, things are going on, and we are going to see it very, very soon. Very soon.
Right.
That's exciting.
But what's the significance of landing on the far side of the moon? Can you talk about it? Because, I mean, we have such advanced telescopes today, all over the world, wherein they can see even the far galaxies, and what kind of star systems exist there. So moon is just like, 380,000 kilometers from here. So, and when it turns, won't the satellites and the cameras and telescopes could see everything around it? So what is the significance of the far side of the moon?
Okay, the far side of the moon is very complicated to reach for several reasons. I mean, if we notice, there were many missions that landed on the moon. I mean, there been the Apollo missions, there were the lunar mission, there were the Chinese, there were other missions to the near side of the moon. And they choose the near side of the moon because, first, for communications is easier, because we can see it. We directly see the near side. So it's easy to communicate from the Earth to the moon directly. And also because they landed in areas that are really flat. That is the mare regions. The mare regions are these areas that we see dark when we see the moon, that we see these dark spots. That's the Maria. Right. These areas are younger, so they have less craters than the older highlands, that is the more light one, and they are flat, so they are safer to go. So we go there are less risk, there are safe communications, and also they land in the equatorial region, so they have quite permanent 14 days of daylight and 14 days of dark. However, what happened in the far side? In the far side, the materials are very light. There's these highlands, so they are really rough. There are a lot of craters, so it's really, really difficult to land. There are some craters, small craters that are flatter, that they have some dark materials, also very new, so they are flat and nice. that is like, for example, the Von Karman crater, that is where the Chinese people landed. But also there is another problem, that is communications. We never see the far side of the moon. So you need to not just make your probe or your lander to go to the far side, you also need to place a communication relay satellite. So the communications works in the way that from the Earth, you send the communication to the satellite, to the lander, and vice versa, from the lander to the satellite, and to the satellite back to the Earth for going back. So that is those are the main problems to go to the moon. Chinese, the country last year or 2 years ago, I think it was 2 years ago, they did it. They place a satellite near the Lagrange point, so the satellite has view to the far side of the moon, but also have view to that is how they are communicating, and so far it's been very successful. So that is the difficult of going to the moon, to the far side of the moon.
So you're saying we, sitting on Earth, can never see the far side of the moon.
No.
I mean, it's so difficult because when it orbits around Earth, it only shows one side of its side. Okay.
Yeah. So it's very difficult for that, because as we cannot see it, everything becomes more complicated.
Right. Great. Thank you so much. Yeah. So you must have heard about Oumua, the asteroid that came a couple of years ago, closer to Earth.
Yes.
So, do you think that it was really an asteroid, or, as doubted by many scientists, including Abigail, that it is an alien probe sent to our solar system for finding alien life by other alien beings somewhere else in the universe? So, yeah, I mean, I was very fascinated and I was following that discussion a lot. He came onto a few podcasts and showed really great evidences of why he thinks Oumua was actually an alien spaceship. What do you think?
Okay, well, I mean, Oumua is really weird. It's really a strange object. The shape is strange. How it moves is weird. We don't understand it. So to be honest, it's like, I don't know what it is. But what I feel is like, usually I think that if you claim that it could be alien object, you should have strong proofs that actually could be an alien object. For example, that it's moved in a weird way, for me, is not proof enough that to say that it's alien technology. I think that it's a natural object. I think that it's a natural object that came from beyond our solar system. I don't know anything else. I don't know what kind of material it can be, because also it's not my side of expertise, but from what I read in the news and in articles, it's like all the researchers are like very like not understanding what's going on with that object. But to be honest, it's like, I don't know what it is, but I feel that it probably is more possibilities that it's a natural object rather than alien technology. But who knows? I don't have
with the current evidence.
Yeah, with the current evidence, it's like but who knows? Maybe it surprised us.
Maybe it was, exactly. And we humans are crazy. Like, we just need a great topic to discuss upon, and then we find some scientific evidence to it, to support it, and then we will just go completely crazy about it, discuss and write publications, do so much scientific experiments on it. And so, but it was great to know that, a lot of scientists like yourself were talking about it all over the world, that, it can be a spaceship as well.
Yeah, the thing is, like, claiming that it's an alien spaceship gives the person a lot of visibility. So actually, when I read about the object when it came up, and then suddenly it was like, it's an alien object, and everybody was talking about that. And it's like, we don't know. Personally, I don't think it's an alien object. But I don't have any evidence. But I think that it's probably a natural object, that it comes from farther, and we don't know. But yeah, I mean, it gives you great headlines saying that it's alien.
Right, exactly. Yes. Who knows? I mean, in the future, with advanced technology, we could have deduced something that, people in the 21st century around 2021 were talking about that it was just an asteroid, but actually it was something, and they missed it because they didn't know, they didn't have the technology to understand it. So
Yeah, who knows?
we never know.
Yeah,
Yeah, exactly.
no.
Yeah, great. Okay. So are humans going to live forever, or will we all extinct by the natural extinction process of nature, or like crazy we will nuke ourselves, extinct due to viruses, or perhaps decimated by an alien civilization? A lot of questions in that.
Yeah. Well, if I had the answer of that, I would be like, I don't know, I would. I don't have the answer of that. I mean, what I know is like what happened before. It's like there were several massive extinction on the history of the Earth. Not just we know, everybody knows the dinosaur extinction, but there were other extinctions previously. There were extinctions that killed practically the 99% of the species of the Earth. So actually, this happened before. What makes us different is like we have technology. We are developing technology to try to survive. So we are going to we are in space. In space is not our logical place to be, but we are surviving there. So we have technology, we have medicine, we have tools that we can use. However, what can happen, I don't know. Forever. What is forever? It's like, I don't know how many more centuries or millennia we are going to survive. But I don't think that the human, or unless the human species as we understand the human species right now, is going to be as we are for infinity time. I mean, at some point, something is going to happen. Maybe part of that, the human race have go to other planet and they are surviving there, but they evolve in a different way there. So are they can be there be considered humans? I don't know. It's like I wish I had an answer to that, but if I had an answer to that, I will be I think I will be millionaire in all the newspapers, and I will be very famous, definitely.
Yeah, makes sense. I mean, the technology part that you mentioned, that other than compared to other animals or other species, that's the differentiating part. For us, we are intelligent and we know how to manipulate things in our climate. We are already doing it in a bad way, but maybe it'll come time in the future that we will be able to make it in a positive way and, like you said, become a multi-planetary species. And then perhaps even if one planet dies because of some reason, somebody nukes it or something, the others can survive. So,
but you mentioned one thing that is really interesting, is the climate. It's like, definitely, if we don't take care of what is going on right now with the climate here on Earth, we will have things more difficult. That's for sure. It's going to be more difficult for us to survive as a species. And the changes are being observed right now. So that is one thing. It's like, okay, we can survive. Yeah, we can build a spaceship to go to other planets or going wherever. But first we should try to minimize, because we cannot go back what we did to the Earth, but we try to minimize or not make it much worse. So actually, I think that if we want to survive, if we want to be longer species, we should put all the technology, all this knowledge that we are acquiring into trying to help population on Earth and to trying to minimize the climate change.
Absolutely, I agree. And I also agree to the fact that people like Elon Musk and others who are trying to make sure that, because in one of several of his talks, actually, he says that, look at humans. I mean, we have no guarantee that we will live here forever due to natural crisis or man-made crisis. So what are the odds that we should let go of our intelligence legacy just like that, like dinosaurs? Dinosaurs didn't have a plan B, where to go. The asteroid came and just bombed them and wiped them out of this earth.
Yeah.
So,
but that speech is really dangerous, because it's like, okay, because that speech sounds a little bit like, okay, we mess up with the earth, so we are going to make something so some privileged people can travel outside. And it's like, but what happens with the rest of the people that we stay here on Earth? I mean, there are many millions of people who are living on Earth who are in danger for the climate change. And it's like, what happened to them?
Correct.
We just simply like, we did it wrong, but hey, don't worry that the human race is going to survive any other place. Like, no, we have to try to solve what we have now. All right, let's try to minimize the impact.
Yes, absolutely. I completely agree on that it's good to think about becoming a multiplanetary species with these entrepreneurs they're doing, but at the same time, it's really important to take care of our existing planet. I mean, this is a gift for us, and we are sort of completely destroying it. So, great discussion, great point. Thank you. In the future, should we merge with AI and machines, then compete with them and get defeated as an ant gets crushed by a human foot? I mean, because it is inevitable. You can see we are living in the age of AI. Most of our things we don't even realize are being done by AI. So what are the odds that in the next 50 to 100 years, AI will not completely take over our lives? So instead of just fighting with the robots like they show in the movies or in the documentaries, why not merge with them and say, okay, we are a part cybernetic species now? What do you think?
Yeah, that I don't know why that question reminds me the start image of Terminator. I mean, I think that robots are actually helping the life of the people already. I mean, there are people with amputated arms or amputated parts of legs that they can benefit of the of robotic technology, and also with AI for people who have some difficulties to talk or some difficulties to move or to everything. The AI can be of great help to them. So actually, definitely, there for me, AI and robots are tools that definitely could improve the quality of life of the humans. The problem is like as in anything, it's like what we do with those tools. It's like having a knife. You can have a knife and you can make an amazing dinner, but also with a knife you can kill a person. So it's like with the AI and with the robots, for me it's the same kind of thing. It's like, yeah, these tools can improve. Definitely, I think that it can get help to make better life of many, many, many people, and we should use it like that. And then for the part of preventing bad uses of these tools, I guess that there should be implemented some laws or some kind of good practices. I don't know. I don't have the answer. Probably at the end, somebody is going to give a bad use to that. Definitely, because humans are like that, and I don't think that we are saints. I think that eventually something, but not because it could be a bad use, we should be against them and not using it for helping. So that is what I think. I don't know if in the future the robots and the AI is going to go its own way and they are going to separate for humans and they are going to be completely independent entities with consciousness and with everything. I don't know, to be honest. But right now I think that there are many things many tools, many research being done that it's really good for many people in the world. And we can use it.
What is consciousness to you, and how do we acquire consciousness? If life happened by the accident of one microbe eating another microbe out of the trillions of microbes eating other microbes under the water, then how does consciousness come into being? Like plants are, they have life, but they might not have consciousness like us. How does that part of differentiating factor comes into us?
Yeah, the problem is like we don't know what is consciousness. I mean, we know that humans have it, but as we don't know, we cannot describe what exactly is consciousness. We really don't know if there are other animals who have them. I mean, I have the feeling, and this is just a feeling, probably I'm going to say something crazy here, but like, for example, that octopus have consciousness. Because sometimes they are not just intelligent, but they understand that they are alive, that they understand their own life. So that is like, but we don't know. It's like, as we don't know what is consciousness, it's like, I mean, I don't have the answer to that neither. Also, I wish I had, but I don't know. So it's like how we acquire the consciousness or what it is exactly, if only humans not have it, is like, I don't know. I mean, for example, for some religions, consciousness is a soul. Personally,
Right.
I don't believe in souls. I don't believe in any gods. So it's like, okay, maybe for me, consciousness is something that is happening in my brain, how the human brains are wired. And I don't know if other animals have them. I don't know. Sometimes I
Right.
see my dog and I have the feeling that he thinks things about me. So it's like,
Yeah.
who knows? It's
Yeah.
like, we don't
That's
know.
right. Right.
So it's like, I don't have the answer to that. I just know that humans seems to have consciousness in most of the cases, and that is
Right.
the only thing that I can say about it, unfortunately.
Yes. No problem. And not just you, but actually everybody in the world is figuring out what exactly is consciousness. What is reality? And are we really living as we see it? Or because of our lack of comprehension of looking outside the three-dimensional world, we don't even know so many things that are around us.
hmm Okay, reality for us, for humans, or for animals, mammals, is
Yeah.
what we see.
Yeah.
Well, in the case of humans, what we see, what we smell, what we touch, is everything that we learn from the environment thanks to our senses. So for us, that is
Correct.
reality. What is the problem? It's like, for example, that our ear only captures a specific range of sounds. Like, for example, a dog can hear much more than us. So we are missing information. The same happens with our
Right.
eyes. With our eyes, we just see a range of colors and a range of wavelengths. So there are other range of wavelengths that we are missing. We have
Correct.
instruments, for example, that help us to see infrared, and then they transform in something that actually we can see. And
Yeah.
that help us to understand more about our reality. The thing is, like, I think that humans are at really very early stage. Practically, we start developing all these technologies and all this science knowledge really recent, just in few centuries ago is when we start to advance quickly, more quickly, and to develop all these technologies to see the world more than actually what we can see and we can experiment in our days. So it's like, okay, I think that reality is what we see, we hear, we smell, we touch, everything, and probably more that we still didn't experience. In the case of there is other dimensions, it's like, yeah, we would never been able to reach those dimensions. Or maybe
That's a
yes, I
great
don't think
point.
so. But it's like,
Yeah.
yeah, it's like probably there is that reality that we will never even think about or reach about it. But in my what I think is like, as soon as we understand everything that, I mean, we have a lot of work to do just understanding what we have around right now. What we can
Exactly.
see and touch and hear and everything, we have enough work to do with that. And yeah, and I mean, there are many theorists, mathematicians, physicists trying to do more theoretical understanding of other realities that may exist or no. But that is theory so far.
But that's a fantastic point because I also think about it a lot that, we have so many limitations. Like you said about hearing, we can only hear in a certain decibel. For viewing, we can only see in a particular wavelength. So there's so many things that we are missing around us,
Yeah.
and that forms our reality. So wow, that's a really great point. Yeah. So yeah, this is the way we are made, and so we can only perceive that as a reality.
Yeah.
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 Are we alone in the universe? There are trillions and trillions of stars, as we know in our observable universe, and we know that with every star there is a habitable planet in the Goldilocks zone. Hence, what is the probability of life emerging in those exoplanets? Can life as complex as ours ever be possible anywhere else on other planets? Not microbes or plants. I mean, pretty much sure that on other planets that would be possible wherever water is and the same conditions as Earth is. But what I'm trying to get onto is life as complex as humans or intelligence who can understand and comprehend everything around them. Is it possible that a life like this can exist somewhere else?
Yeah, well, that is again, another question that I have to answer with, I don't know. But I mean, definitely intelligent life has arisen at least once on the earth. So with the history, the history of the universe, plus the trillions of millions of stars with many, many, many planets that could be habitable, it could happen. It could go either way. It could happen that intelligent life arise again, or it could happen that no, that maybe it was so difficult to create intelligence that actually just happened once. But it could go either way. So again, it's like so many of these questions I have to reply with, I mean, I don't know, but it's good. It's good to say I don't know, because it's like, I think that when you don't know something is what makes you to go and explore and learn.
Right.
That if you know everything, you just sit and enjoy watching Netflix or whatever. But when you don't know, it's when you start to read and start to understand what is going on. So yeah.
That's a great point. Yes. But I mean, what I was trying to ask you was that, you know, sometimes we just think in our heads, it's my perception, it can be wrong, and it has no evidence behind it. But it's my perception that maybe somewhere in some other galaxy, there might be planets and star systems like ours where life like us can exist. But at the same time, they cannot contact us. We cannot contact them because of the vastness of space among us. I mean, how will you even reach to other star system if you cannot just communicate through radio transmission or any kind of transmission?
Yeah, the thing is like, it's well point what you say. It's like, because sometimes if it's that far, that actually there is no way to communicate with them or have any type of contact at all with them, why would care? It's like, for that point, we are alone anyway. I mean, if we cannot communicate, it's like if we were alone, if we cannot do anything with that. So it's like, okay, for me, what I care is like, if we can find intelligence life within an area around us that actually we can communicate and is feasible contact. If not, I don't care if there is 1 or 10 civilizations or thousands, if I cannot reach them. It's like,
I agree.
Because for the fact it's like I'm alone. I mean, I would love to know.
Yeah.
But we cannot.
Yeah, exactly.
We cannot do anything.
Anything about it.
Yeah.
That's absolutely right.
Yeah.
Okay. So what is the meaning of life, and why are we here in this universe, as per you? Or there is no meaning and it is just pointless to discuss it. We just exist due to the miraculous way in which life has started some billion years ago.
Yeah, that is a really complicated question. And actually, it's like this question, now that you are telling me, it reminds me of another film. I love films. And it's another film. I don't know if you're familiar with Monty Python. So the Monty Python is a comedy group from the 70s. So they have a movie that is called The Meaning of Life. And they try to solve the mystery. It's a comedy. The mystery of what is the comedy, what is the meaning of life. For me, when I watch that movie, when you reach the end, it's like, okay, the life has no meaning. And that is what actually I think. It's like, I think life has no meaning. It was just a luck that I'm here. I'm really lucky of being alive. I'm lucky of my family. I'm lucky of being working in what I like to do. So for me, I'm lucky of having amazing friends around me. So that is what for me is important. And that is what for me means my life. It's like, enjoy my time here, spend time with my friends, with the people I love, do what I am enjoying, working what I enjoy the most, that is being planetary scientist. And for me, that is what it counts. It's like, after that, I don't think we are here for serve any ulterior purpose. We are just here. I believe that we are just in life once. So we have to take as maximum as we can from that. And especially that means it's like trying, I mean, we are not going to be happy all time continuously. But unless that, for me, what I want is like when I get old and I'm just sitting in a chair, looking back, and I say, wow, I enjoy to the maximum. I read what I like, and I explore. I spend sometimes with my son, with the people I love, and that is what is for me important. That is what for me means being alive. Yeah.
Fantastic. That's a great answer.
Thank you.
Pragmatic, very practical. Yeah.
Yeah.
So this is a great way to end our podcast, Abigail. It was a great pleasure to have you and to discuss with you all these questions and topics that I have. I would also request you to come again whenever time permits, and we can sit, and then I will bother you with some more uh, questions about some other topics in our universe and science.
Thank you very much. It was a pleasure to be here. I really enjoyed this conversation, and I'm really happy to come back and continue talking about consciousness, meaning of life, or whatever you want to ask me to talk about. Thank you very much.
We will do that.
Thank you.
Thank you, and you have a great day.
You too. Bye.
Thank you. Thank you for listening to this podcast. Please support this podcast by liking, commenting, sharing it with your friends, and also subscribing to this channel. Thank you, and we'll see you next time.